The next example is called data envelopment analysis. Okay, there it is, DEA. And we can use this data envelopment analysis in a linear programming setup to see whether the particular company that we are considering is operating in an efficient way or not compared to the other companies that are in the industry. So in this example we have hospitals. So we have 3 hospitals. It can be any number of hospitals. And we look at a certain group of inputs and a certain group of outputs. Now, if an operation is efficient, then you will produce as much output as possible with as little input as possible. Okay, so that's the most efficient operation. So you compare the other companies within an industry with your own, and then you price your inputs and price your output and see whether there is some pricing in which you are able to at least perform as well as other companies. So here it is hospitals. So to keep the example simple, we are considering only 2 inputs, and how much of these inputs are used in the different hospitals we are considering. So maybe we own all the 3 hospitals and then we are analyzing the efficiency of all the hospitals. Or we could be one of the hospitals and we are considering ourselves against the others in the industry. Okay. So how much of these inputs are we using? So input 1 is capital, input 2 is labor. Okay, this is data that we collect from the different hospitals. And then we have 3 different outputs. So hundreds of patient days of age under 14, 14 to 65, 65. So this is again data that we have collected. And now we want to price these inputs and outputs in the best possible way, such that for a given hospital, what is the efficiency rating? That's what we want to find out. So let's go to the Excel file. Okay. So here this is the input. This is the input, and these are the outputs. Okay. Now we want to price these inputs. Okay, so that's what we want to find. Is there a pricing? Is it possible to price these inputs and outputs in such a way that the input costs are greater than output values, obviously because you cannot have more output value than input value, for a selected hospital. So we'll give a name here and we can run this for different hospitals or different companies, whatever, in the case there are different companies. So let's give a name there. So this is unit cost of inputs. We'll give a name here. Unit prices of outputs. Okay. So now the input costs are some products of the pricing or costing in this case with the inputs actually used. So this will be for a given pricing, this will be the costs of these different hospitals. Now output value will be some product of the output pricing with those outputs. Okay. Now for our purposes, the inputs valuation must be greater than output valuation. Okay. Now we need to set the input cost for the selected company or selected hospital to 1. Okay, so that way, if the output is 1, the input is 1, output is 1, then that's the most efficient operation. Okay, if the output is less than 1, then we know that it could operate in a better way. So the efficiency is less than optimal. Okay. So what is the selected input cost? Okay. So here selected hospital is 1. Okay. So we need that would be the selected hospital's input costs. You want to model this in such a way that you can automatically generate the outputs for any of the 3 hospitals that you've selected. So we're going to use the VLOOKUP function, okay, with the selected hospital, okay, and we will use that as our input lookup table. Okay, well, let's do an F4 of that. Okay, comma, the input costs are in the second column. Okay, so this way, when you change the selected hospital to 2, then the input of the second hospital will show up here, and so on. Now let's copy that here. Okay, again another VLOOKUP, selected hospital, same VLOOKUP table. Here we'll change that to 4, which is the output. So here it is input, here it is output. Now we want pricing for the inputs and the outputs in such a way that the input for the selected hospital is 1. We want to see what the output valuation will be for that selected hospital. Okay. So input costs and output values must be named now. Okay. Selected hospital input cost and selected hospital output value. Now this is the objective function. So let's and we want to maximize that. Let's go to solver and maximize, and the to pricing. Okay. The constraints are that the input costs are greater than output values. That's 1. And then the selected hospital input is equal to 1. Okay, now I'll make that simplex LP. We solve. So now we have a pricing structure such that the selected hospital's output value is equal to the input. So we have 100% efficiency for the selected hospital. Okay. What if we want to run this for the second hospital or not the first one? So change that to 2 and you run solver, and now you get the second hospital, and you see the second hospital, the efficiency is not there. It's not 1. The output value, even the best possible input pricing and output pricing does not give you the output valuation of 1. Now change that to 3. Let's solve again. Now you see the third hospital is efficient. So this is assuming even the best practices. Okay, this is the best that the hospital could do. So hospital 2 is definitely not as efficiently operating as the other 2 hospitals. Now how can we be so sure that hospital 2 is not operating as efficiently as it could? Now we can run, okay, let's put this back to 1. We can even run a solver table and use this as the input and look at 1, 2, and 3 hospitals, and we will have the information. So let's do a solver table, one-way table with that as the input, and we want to go from 1 to 3 in increments of 1, and we want the output to be that. Okay. Now you run and you see that the efficiency results are 1.773 and 1. So hospital 2, even giving the benefit of the doubt, it's the best pricing for input and best pricing for output, still comes out short. And another way of looking at this and then seeing in what way 2 is not performing as well as 1 and 3, we can take a look at it in this fashion. So here is the input and output valuation, the inputs used and outputs used, the given information. Now if we take the second hospital out of the picture, okay, so let's move it down to here. Okay, so let's get rid of this row. Now, is there any way of combining these two hospitals, 1 and 3? Now, in your textbook, there is a typo. This is given as hospital 2, which actually it should be 3. Is there a combination of these two hospitals in input and output in such a way that you can use less input than hospital 2 for this combination hospital and yet produce more output, or at least this many output as hospital 2? So let's add a couple of columns here. Okay, we could go and insert columns. Okay, so what we're going to do is we're going to set up a weight. Okay, it can be any weight, doesn't matter, and we'll make weight as our decision variable. Okay, weight is the decision variable, and let's give a name for the weight. Okay. So now what we want to do is to do a sum product of the weight with the input. So that will be a weighted average of these two hospitals which are operating at better efficiency. Okay. Now we want to see whether there is any weight possible that uses less input than hospital 2 is actually using right now. And you copy this for the output, and here we want to achieve for that same weight at least as many outputs as hospital 2. So is there a weight combination in which we use less than or equal to the input hospital 2 is currently using and produce greater than or equal to output that hospital 2 is currently producing? Okay. And another unique feature of this analysis is that in solver we really don't have any objective function. All we want is to determine the weights in such a way that these two constraints are met. Input for the combination is less than or equal to input currently used. Now, output for the combination hospital is greater than or equal to the output hospital 2 is currently producing. Okay. You solve and you see for this weight the combination hospital, so let's call this combination hospital. Okay, so uses less input and produces at least as much or more output. So this clearly shows that hospital 2 is not operating at the same efficiency as the other two hospitals. So this is called data envelope analysis. Once you have done that, once you have identified the non-efficient resource or non-efficient operation, then you can set goals for improvement, and this analysis gives you some pathway to determining what should be done or what improvements are to be instituted.